Hi, welcome everyone. Thanks for joining this webinar today with Huawei and OpenIO to talk about the benefits of object storage. I am Mary Poncel, co-founder and VP of Marketing at OpenIO. Few points before we start, this webinar is recorded. The video will be sent a few days after this session. If you have any question or feedback, feel free to ask them at any time in the GoToWebinar app. We'll be happy to answer. So you will find one attached document in the GoToWebinar app. It's a document that describes object storage and serverless computing. You can download it by clicking on the Documents panel in the app. I'm now happy to introduce our three speakers for the day, who are Enrico Signoretti, Head of Product Strategy at OpenIO. Welcome, Enrico.
Welcome. Welcome to everyone.
Maxime Thomas, Pre-Sales Engineer at OpenIO. Welcome, Maxime.
Hi, everybody.
And Luca Gerzik, Senior IT Solution Product Manager at Huawei. Welcome, Luca.
Thank you. Good morning, everyone.
So the agenda today is divided in several parts. First, Enrico will briefly introduce the benefits of object storage. Then Maxime will make a quick live demo showing how easy it is to deploy an object storage with OpenIO. After the demo, Luca will present the RH2288 server that is going to be certified for OpenIO. We also talk about the Huawei and OpenIO partnership, and then Huawei in the European market. So before starting, I would like to submit a quick poll. So here's the question. We would like to know what is the size of the largest storage infrastructure that you are managing, if you are managing any. So is it less than 100 terabytes, between 100 terabytes and 500 terabytes, between 500 terabytes and 1 petabyte, or more than 1 petabyte? So I'll let you a few seconds to answer. Okay. Okay. Thank you very much. So I am now letting Enrico starting with the first point.
Thank you very much, Marie, and thank you everyone for joining us today. My presentation will be on the benefits of object storage and the differentiator that there are between OpenIO and the rest of the market. So let's start with a quick look around us. There are a few trends in the market at the moment. One is that everybody's talking multi-cloud, so the ability to deploy your application and your infrastructure not just on premises as it was a few years ago, but now cloud is important. Not everybody is going on the public cloud for everything. Many enterprises are understanding right now that public cloud is good for flexibility, but sometimes the costs are really, really high. So they are trying to have a balance between different technologies and different offerings that they find on the market. At the same time, there is a huge wave of new kind of application, and one of these is Internet of Things. I was just yesterday with a customer talking about a very, very standard manufacturing company, and they are rebuilding all their machinery to support Internet of Things. They are getting sensor, they are measuring everything, they are building analytics application on top of it, they are storing data both locally and on the cloud and on premises, and now they are connecting all of this information to give more and more information to the customer, but also to the sales and to the service department and so on. And at the same time, all this data that we are creating has to be understood because it's useless to have petabytes and petabytes of data without something that can help to understand the content better. So machine learning and artificial intelligence are keys to that. Okay, this is not just buzzwords. This is not just the phone that can talk to us. It's just how we can learn about the content that that is stored in our systems. And last but not least, there is a great split at the moment between different kinds of storage. Okay, traditional storage is no longer the focus for most of the companies. In many ways, you find that performance, and when I think about performance, I think about all-flash arrays, in-memory storage, where you look for the best latency and the best performance is the key to manage databases or all the kind of data that is changing very, very quickly. At the same time, if you're looking for capacity, you're looking for a scale-out system, now object storage. You are looking for the best dollar per gigabyte because you have to spend. You must spend as less as possible to make it sustainable. And so there is this kind of new infrastructures that see performance storage on one side and capacity storage on the other. So if we look at object storage, okay, you can think that more than 88% of data, and it's growing faster. Many analysts are already targeting numbers above 90%, 93% in 2020 for IDC, for example, and it's in the latest report. And it's very important to see that this data is usually unstructured, so not databases, but images, pictures in general, or sensors, many different kind of data that are not structured in a database. And this kind of data needs low frequency modifications. Sometimes it's really immutable, in the sense that you write it once and you never read it again. And bandwidth is very, very important, as well as the price per gigabyte, as I said before. It's there are several use cases for object storage. Okay, there are some traditional use cases that start with the email platforms that are, if you think at email, okay, you receive an email and this is a small object, okay, with a lot of information on the content of the email, attachments and so on. So this is perfect for object storage. But media entertainment, streaming files that are huge movies, private cloud storage for applications that now are in our own infrastructure, but they are served through web user interfaces. Remote storage consolidation, NAS on the remote locations and remote offices with concentration of data at the core. Backup and archiving. All the backup software now use object storage interfaces to as backup targets. And big data, building big data lakes is much easier with object storage than with anything else. At the same time, okay, we serve this with our SDS platform. At the same time, there are some applications that some of them I already described, like integrated data processing, industrial Internet of Things, machine learning. Well, there is more to the data, to the object storage itself. We developed a framework that allows you to run application directly into the object store. So you can get value directly from the data you are storing. And I will talk about this more later. So what are the characteristics of object storage? First of all, what is an object? An object is a file. At the end of the day, it's your picture, a log file, whatever, okay? And we usually add metadata on the top of the file so we can create the object, okay? The metadata is a description of the content. You have metadata also in file system, okay? Metadata could be the author of the file and the date when the file is created, but actually in a file system they are very, very limited. You can implement as metadata as you want in an object, okay, and they can be really, really descriptive, okay. So you can describe actually the content. So if you have an image with some bananas in it, you can have a meta tag with description banana. And so it's very, very powerful, makes the object searchable, and it's much more relevant than just a file with a name and the data and the date. Okay, the object is unique in the system, so the sum of these two plus generates a key, and it's unique in the system. Okay, if you create two objects that are actually identical, they will be two files. So if you say two files in the same object store, the two files will become two different objects, and they will have two different keys. Why object storage? Object storage is different from other forms of storage for several reasons. The first, if you look at block storage, for example, it's a storage that you find in a data center, and it is very close to the servers. Okay, protocols are FC or iSCSI usually, and a single volume is accessed by a single server. Okay, and it's very good to get the best in terms of IOPS per second. The latency is very, very low, and consistency in the performance is very, very high. Okay, but this kind of storage has a problem. It doesn't scale, okay, usually, and also it doesn't serve too many applications at the same time. Then there is file storage, okay, usually NAS, network attached storage. Okay, it's local to the network. It's accessible to from many clients at the same time, okay, and it supports file protocol, SMB and FS usually, okay. One single volume of data is accessed by many PCs or many servers at the same time. The latency is higher because it's not as close as to the server as it was for the block device, but it still maintains a good performance both in throughput and I/O per second. Still, it's a scale-up solution. It's a very limited scale-out functionality. A few of this solution can reach multi-petabyte environments, and they become very, very costly, very, very expensive when they reach this kind of level. Then there is object storage. Okay, object storage is different because it's accessible from everywhere and from any device. It's this happened because it is accessible via HTTP protocol. Okay, the same protocol that runs the internet. The same object can be accessed by millions of devices. Think about you take a picture and then you share it on a social network. Okay, if your post is accessed by million devices, okay, this is the same object accessed on an object store by millions and millions of persons, for example. Okay, so you need a high throughput, you need a very high parallelism, and you need unfortunately the latency is higher for when compared to other systems. But it's not higher just because the object store, it's higher because you are accessing it through a network that is unreliable. Okay, so 3G networks there are in other kind of networks in the middle, so it's a little bit more complicated. Another huge difference is the scalability. Okay, most object store can start to several petabytes and also exabytes, so very huge installation can be achieved with the object storage. So in fact, when we talk about object storage, we don't talk about storage system, but we talk more about storage infrastructure. By its nature, the object store can serve many workloads at the same time. Okay, so this is just again examples of the kind of workload you can serve on an object store. Okay, and the interesting thing is not what you can do, but the fact that you can do it at the same time on the same infrastructure. So the same object store can do archiving, backup, file services, and it's the same infrastructure in the backend. It's just you add the gateways or you add protocols, and it works. And of course, there is this performance issue, okay, which is actually not an issue because most of the data is cached on the front-end application and on the gateway. Think about, for example, Dropbox. Okay, Dropbox is a very common application. The backend of Dropbox is an object store. The front-end, okay, it's a client that show you files like they were local. Actually, they are local because they are cached locally. Okay, so you have local performance, but very, very inexpensive backend and very scalable backend. That said, what we do at OpenIO? So we do two things. One is next generation object storage, and the other one is serverless computing. Okay. For the next generation object storage, we solve we give a better dollar per gigabyte. Okay, this is one of the best dollar per gigabyte of the market, which means that if you have an application that needs to scale and to store more data, this is the best solution you can find on the market. At the same time, we solve another problem. We create more value from data stored in our storage because we can do computing directly at the storage level. Okay, and there are several applications, and I will describe one of them later. Okay, there are several object storage in the market, and they are all very similar. Okay, some of them are very, very similar characteristics. What's the difference between OpenIO and all the others? Well, first of all, okay, OpenIO is a software. Okay, we install the software on standard x86 hardware. By doing that, we create this hyper-scalable storage and compute platform. It can start with 3 nodes, but actually we can scale up to hundreds of petabytes, of thousands of petabytes. So lightweight design is our mantra. It means that we can install the software in very large data center infrastructures, and that can serve millions of devices at the same time, millions of clients at the same time, but we can also install the software on a device as small as this one. This is a Raspberry, okay, it's a $5 computer, and our software can run on it. It means that you can use it for IoT installation as well as a large data center installation, and this is the same identical platform. So it's easy to replicate data from the edge to the core. Okay, our software is also really, really flexible, meaning that by using different technology, we can overcome the limitation that you usually find on other object store. For example, we use a directory mechanism that is distributed on the cluster, and it's a little bit different from what you usually find in other object stores. For example, many object stores use a ring layout, and the ring layout has a problem. Okay, all the data is distributed on all the nodes. Okay, and by doing so, all the hash table that is used to find the objects is distributed on all the nodes. It scales very, very well, But actually, from the performance point of view, there are a few problems, because by adding more and more nodes, the number of hops that you have to do to find the objects increases. And it means the larger the cluster, the slower the performance. Okay, with our mechanism, you don't need to do that. Okay, we grant that in 3 hops you will always reach your object. So performance, no matter the size of the cluster, is always very, very consistent. At the same time, not using this very, very static mechanism, which is the traditional hash table, distributed hash table, we have the ability to add nodes, new resources to the cluster without rebalancing it. Okay, rebalancing a very large cluster means that from the day you install new nodes and the day that you can use these nodes in production, the time is a lot. Okay, to rebalance a traditional cluster could take hours if it's small, but days or even weeks if it's very, very large. Okay, so with OpenIO, you just add a node, and in 2 minutes you are ready to use it. To balance data in the cluster, we use conscious technology. It's a very, very simple idea. We measure in real time from all the nodes what they are doing, everything. Okay, bandwidth available, capacity available, CPU, and so on. But we can compute a score, a quality score for each single node, and we always choose the best node where to put data. That means that there is this load balancing mechanism which is very, very dynamic, and each single node that you add, so a new node, is treated in the cluster, is added in the cluster, and it gives a better score, so it will be hit more than others. Okay, and last but not least, the integrated grid for apps gives you the ability to do more operation on the storage. So each single event that is performed on the storage, store, update of an object, delete of an object, okay, creates an event, and the event is can be intercepted by an application to do something. So we have several components of the object store that are open source. Okay, all the yellow boxes are open source. So everything that I described can be done by downloading the software, installing it, and in a few minutes. The red components are additional components that the customer can buy and or are delivered with support services. So again, our approach is efficiency. We have a very lightweight design. We have grid for apps that increments the value of data stored in it, and we have the ability to use multiple very flexible data protection schemes for protecting the data. We are very flexible, so dynamic load balancing and all the cluster. We can use heterogeneous hardware. So if you are going to implement a cluster today, and in 6 months, 9 months, whatever, 3 years, you will need additional nodes. You will be able to buy the nodes that will be available that date, and because of the dynamic load balancing, you will take advantage of all the new resources, no matter if it's 10 times faster or even slower. Okay, we have an automatic tiering mechanism, so we can mix flash and disks in the same cluster, and there is a lot of freedom of choice. Okay, you can implement the cluster to distribute data geographically. There is an hybrid tiering option, so the cluster could copy unused data to the cloud. You can install it on the public cloud, or you can build configuration that are spread between on-premises and the cloud. It's an open source solution, so for the lowest of the TCO, it's a software defined. Okay, so you split hardware acquisition from software acquisitions, and it's really easy to use. So just to demonstrate how easy is to use our software, my colleague Maxime will take from here. I'm just handing over the here you go, and he will demonstrate how the software works. Maxime?
Thank you very much, Enrico. So I'm going to show you now how easy it is to deploy a production-ready OpenIO cluster by using our web UI interface, web UI managing stuff. So let's do it. Let's connect to the web UI. The first time you connect, you will need to create a namespace. So let's call it OpenIO. As you can see, there is no node yet in the web UI. So you will need to add a new node, or at least 3 nodes for a production-ready cluster. And here are my nodes. Our application runs on Linux. So here I'm using Ubuntu on every node. And I will have to run one single CLI operation to link it to our web UI. So let's add 3 nodes now. And as you can see, they are linked. Oh, let's wait for the last one. Okay, so our 3 nodes are here. We will need to bootstrap the cluster, and thanks to the little wizard, we can do it very easily. So we will select all the 3 nodes, and well, choose our configuration. You can edit it if you want, but we will use for this demo the default configuration, the default storage policy too, and we will deploy the application. So we got a job manager showing all the jobs running. You can find it here also. And while it's bootstrapping the cluster, I will show you that you can really set up all the configuration of each services and edit it after you've deployed your first cluster, and also your storage policy. So you can add your own policy that fits your need as you like. The web UI also provide you a monitoring on each node, so you can monitor the network, the storage, and the CPU usage. Storage is at 0 for now because there is no service running yet on it. Let's wait a bit. Okay. So now, if we zoom in, we can see that there is several services on it, and we will need to unlock all the scores because, as Enrico told you before, we use the conscience technology to compute the quality score for every services, and by default, when you add a node, it will be locked at 0, so not available, and we will unlock it just to be able to use the cluster. So here it is. Now I'm gonna use little application we have created for the community and for the demo, which is not production ready at all, called OYO Browser, and well, that will allow me to send some object directly on the cluster and use the OpenIO cluster we just created to store my data. the brother use an account named demo, and I will upload some files in a container named img. So let's do this. My picture is uploaded now, and I can locate it on my nodes by running this little tool. So my account is demo, my container is img, and my file is called img0.jpg, and I can locate it. And as you can see, it's stored on each node because we are in a 3-time replication data policy. So we got a chunk on each node. Now I will add a new node, okay, called node number 4, exactly the same way, and we do not need any rebalancing of data. So I will just run this command once again, and well, now you can use and assign this new server, this new node, to your existing cluster. Let's assign it. So as you can see, it will provide, oh, you can see the score here. As you can see, it will create 2 services, and then I'll just have to commit the changes, and the node will be added to the cluster. Once again, it will be added with a score lock at 0, so we will have to unlock the score for this new node so that we can use it. Let's wait a bit. So now the new node is ready, and I will just unlock the scores. Okay, so you can use it. You can use it now. I will send more pictures in the cluster, so that, as you know, we are not able to know before where the data will be stored. So I will send more than one file just to be sure that I can, at least one will be in the 4th node. So let's do the same operation. Let's locate the data, demo container img, and let's find the img2, for instance. And it doesn't exist, it's the 12. No, yes. So let's find something else, the 9. Okay, so did I upload it? Yes. Okay, so it has been longer. As you can see, we are using the node number 4 now directly in our cluster. So it is very easy to deploy and bootstrap the first cluster. And when you need some more space, some more volumetry, you just have to add 1 node or 2. It's very easy to, and do not need any rebalancing of the old data. This is it. So I will give the lead to Luca from Huawei.
Yeah, thank you.
Who will explain.
Thank you very much, Maxime.
Okay.
Thank you. Thank you very much, Maxime. If you guys have some questions about this first part, please ask them in the app. We'll tackle them at the end of the session. So, okay, Luca is going to introduce the next part.
Okay. Luca, you have control of the screen.
Thank you, Enrico. Good morning, ladies and gentlemen. Welcome to Huawei and OpenIO webinar. My name is Luka Gerzic, and I work in Huawei as Senior IT Solution Manager responsible for Western Europe region. and today I will be presenting you one of the Huawei server products, namely 2U servers 2288 V3 and V5 that are used in OpenIO projects. Before talking about our products, let me give you a quick introduction about the Huawei company. Our company has three major business groups: consumer business, carrier business, and enterprise business. Servers and storage products belong to the enterprise business group, while carrier is reserved only for large telecom carriers customers, and the consumer business group is for our mobile phones, tablets, and other consumer products. We have a couple of milestones, and we marked them in recent years. Mainly in 2015, we passed 60 billion US dollars revenue, while in the same time investing almost 10 billion US dollars in our research and development. Only in Europe, we have around 10,000 employees, 2 regional headquarters, and we are present in 33 European countries. Our industry footsteps will show you that we are in server business since 2002, but at that time we are closed for general public, working directly with only large telecoms and carriers. In 2007, Huawei started heavy investments into research and development for enterprise products, and in 2011 we started doing business with the general public. In recent years, we made many breakthroughs, and just recently we announced our first 32-socket x86 server named Kunlun, which is capable of addressing 32 terabytes of memory. Huawei has 4 planning directions, namely scale up, scale out, converged, and I/O acceleration. And today we are going to talk about scale out product range where our 2U solution reside. I would like to highlight that Huawei focus on stable and reliable system design in all our products, as we have vast knowledge and experience implementing telco solutions that require very high standards. Namely, we have our own server management chips that are implemented together with other solutions that we use in our servers, mainly patented shock absorption designs in these carriers and chassis. Huawei servers are also capable of stable running up to 45 degrees temperature. All components used in building servers are carrier grade quality, including gold-plated connectors and polymer capacitors. We do consider our servers to be building blocks for our customer projects. We can enable you to create stable and reliable projects on top of Huawei servers, and one of the great examples of this is our cooperation with OpenIO, where Huawei servers enable OpenIO to create stable and reliable solutions for next generation object storage solutions and infrastructures. Talking about our own server management chips, I would like to introduce Huawei IBMC out-of-band management system. Our chip provides you with full insights of how server operates, while at the same time provides you easy access to management interface. One thing that I would like to highlight here is that all features, including virtual KVM, serial over LAN, Blackbox, and all others, are included in a server with a single license. And since Huawei is the manufacturer of our own BMC chips, SSD chips, and NVMe controllers, we can better control the total server costs. One of the things that I personally very much like is the Blackbox. Blackbox is one of the features of Huawei servers that will provide you with full insight of any issue with the server, like for example in case of the software crash, like a kernel panic or similar situation. Blackbox will record 60 seconds of video and images that happened before crash, so you can analyze the events that lead to the server downtime. Personally, as an engineer, this is, in my opinion, a valuable option for your engineering team in case of any kind of troubleshooting. And as I have already mentioned, all our products are carrier-grade quality builds and tested them. I usually show some details regarding how we test our products with the video material. But now I will just mention that we do highly accelerated live tests, ESD tests, fire tests as our component, for example, inside the server must not catch fire even if they are exposed directly to the flame, and many other tests for quality and reliability of our products. This is the server that we are going to talk about today. RH2288 servers have few versions of chassis depending on the number of disks you need in the server. Here we can see 4 versions with 2.5-inch drives and 3.5-inch hard drives. Internal components of the 2288 are all modular but design and can be easily removed or replaced without any tools, as our products are in toolless by design. Cooling of the server is hot swappable, so all fans can be removed while the server is running, and the same thing is with the power supplied units. All our PSUs are made with power efficiency in mind, and we are proud to tell you that all PSUs are 88 platinum or titanium grade by efficiency. At the back of the server, we have option to replace PCI Express caddies with HDD caddies for increased HDD capacity in the servers. Depending on the server, you can increase the total capacity of our V5 solution up to 23.5-inch hard drives in 2U server size, which is especially interesting for projects like OpenIO. I will just briefly mention that all our solutions do support NVMe drives, and depending on your needs, we can fit up to 24 NVMe drives in our 2U servers. These are just 3 examples of how we can distribute the NVMe drives in 2288 server. Here is our comparison of the V3 and the new V5 series that just got out. And as you can see, we improved design, increased the capacity, so you're not going to use Intel Skylake CPUs up to 28 cores per CPU with the new DIMMs capacities up to 128 gigabytes of memory per 1 DIMM, with up to 23.5-inch hard drives, as I already mentioned, and up to 24 NVMe SSD drives and the new titanium power supply units. I will also again highlight that our servers can continuously run on 45 degrees, and that this will enable data centers and you to cut costs by, of cooling by increasing working ambient temperatures. And as my last slide, I would like to point out that Huawei is a strong supporter of open source solutions, and that our developers contribute to many open source solutions. One of major contributions from our side is for the OpenStack Cloud and many other solutions that are reside in the open source community. We have also our own Cloud OS and many different solutions for big data. Thank you very much.
Okay.
Great, thanks a lot, Luca.
So I'll take over again for just the last slide, where I want just to mention that we are working with Huawei at OpenIO to get the solution certified on several servers. Okay, we started with this first 2 rack unit server, but others will join this. We are going to publish best practices on how to install and manage the end-to-end solution, and training courses will be available later this year, as well as pre-sale support for all the reseller system integrators across Europe. And there are some interesting news that we'll announce later, probably at the beginning of 2018, because we are working closely with the Huawei team to do more. And I think with this one, we have concluded the presentation, I don't know, Marie, if you want.
Yeah. Before going to start the Q&A session, I would like to submit a second quick poll. So what are you looking first when you or your customer buy storage today? Is it the cost, the overall performance, the scalability, the availability, or the resiliency? Let's use a few seconds to answer. Okay. Thank you.
Nice to see that 80% of
yeah, and in fact, I can share you directly the result. So the first question was about the size of the largest platform infrastructure you are managing, and we have 45%, less than 100 terabytes, 36% between 100 terabyte and 500 terabyte, and 9% each for the bigger size. And for the second question, yes, it's all about, I mean, 78% about the cost, and then scalability and overall performance, availability, and resiliency. Okay. So we have a few questions. I take the first one, probably for Enrico. Is it possible to try OpenIO object storage solution?
Yes, so the product is available, is open source, and is available for free download. And there is documentation on our website on how to install it on Linux servers. We support CentOS and Ubuntu. There is also a Docker container available, which simplifies everything. Just if you are familiar with Docker, you install Docker on your laptop, and you just pull the image, and you can start playing with it. Of course, the Docker image is not a production environment, but it's just to test the functionalities and all the rest.
Okay, the second one is, what is the minimal installation for OpenIO SDS?
As I told you already, there is a Docker container, so minimal installation is really, really minimal. And but for a minimal production environment, it's 3 nodes, and each single node has needs an hard disk at least. Usually, because the licensing, etc., the minimal viable installation is several terabytes for each single node.
Okay, thank you. Which protocol are supported by OpenIO SDS? I'm interested to know more about file support.
Well, so we support all the object storage, the most common object storage protocol, S3, which is Amazon S3 compatible, of course, and Swift, which is OpenStack Swift compatible, of course. And on top of it, we have a gateway, which is a file gateway that just show you a container as a file system. So you can share this container as a file system through NFS and SMB. That's the usual protocols that we provide.
Okay, thank you, Enrico. Another one, are there already reference cases in the Netherlands?
Not in the Netherlands. There are cases in Sweden, France, and other countries. Unfortunately, we do not have a customer in the Netherlands yet.
We work on it.
You are working on it, yes.
Yeah. In case we chose the certified solution, OpenIO plus Huawei, who's the first contact for support, and who is responsible for hardware support?
So we manage all the software support, and the hardware support is on Huawei. In some countries, we have distributors or resellers that can manage the first level support on about also our solution, so they can do the first level support for both. We are working with Huawei on a more integrated solution for 2018. So the customer, it's still a preliminary stage, so I'm not sure that we will have it, but we are working to have everything from Huawei, like the appliance that you can buy with licenses included.
And I have the last one, Enrico. How is the licensing?
License is pretty simple and straightforward. We do not have a license in the traditional terms. We have a support fee, and it's per terabyte basis. So, like for many other open source solution, the code is available online, and the license is AGPL, and you just buy the support, which is per terabyte.
Okay, thanks a lot. It was the last one. So thanks everyone for your time. Thanks Enrico, thanks Maxime, thanks Luca. If you want to continue the discussion, you can find a lot of information on our website, openio.io and huawei.com. If anybody has additional question or feedback, please reach out. We'll be very happy to answer. You will receive the record of the webinar in the next few days. So I wish you a very nice day, and I hope to see you next time.
Thank you very much. Bye-bye.
Bye-bye, everyone.